Before using Science+C, my students could define a concept, they could calculate the concept, but I wanted more. I wanted my students to be able to apply the concept. And in Science+C, the students are required to explain what they see on the screen, explain why they see it, but even more, how. How does it happen? The students go into the code and see how does it actually happen. That's what sets Science+C apart.
Prior to using the models, it was a lot of paper pencil, it was a lot of drawing pictures and trying to help the kids see these concepts that they just couldn't picture. And then after I used Science+C, my students could actually see carbon dioxide molecules. They could actually see a chloroplast and what was going into the chloroplast and what was coming out of the chloroplast. And it just wasn't me writing CO2 on the board into a fake chloroplast. Like, they could actually see these things moving.
I would like science teachers who are new to Science+C to know that you're not doing more, you're doing it more effectively.
According to the U.S. Bureau of Labor Statistics, science, technology, engineering, and mathematics, or STEM jobs, are projected to grow over 2 times faster than the total for all occupations in the next decade, and most of the STEM careers are going to be in computing. So, it is essential to build student skills in STEM and computer science together. Currently, only a little over half of public high schools across the U.S. offer at least one foundational computer science class. And in states with enrollment data, only 4.7% of high school students are enrolled in foundational computer science. All students should have the opportunity to build computational skills as part of their regular high school curriculum. Science+C is an interactive computer modeling and simulation platform focused on building computational thinking skills embedded within units of core biology, chemistry, and physics courses that every student takes in high school. By integrating computer science into these core high school science courses, Science+C addresses issues of access and equity by offering traditionally underserved students a way to learn about computer modeling and its applications to real-world contexts and phenomena.
Science+C has brought a lot of equity into my classroom. I teach students who are on 504s or IEPs, and this particular program brings a lot of varying differentiation in their modifications so that I could have students who are at a higher level do one sort of modification and students who might be at a lower level do a different modification but still come out to the same goal and be able to answer the same questions.
Some of my students were not sure about Science+C, but when they were successful decoding the procedures, and even more so when they could successfully modify the code to change the simulation, they were so excited.
Each Science+C unit introduces computer modeling via a use, decode, and modify progression to strengthen students' understanding of scientific processes and show the power of computational methods and tools for scientific inquiry. In the use phase, students explore the model and run experiments. In the decode phase, students identify the science concepts embedded in code and discover how the execution of the model's code drives the simulation. In the modify phase, students assess the validity of the model in terms of whether it matches what they know about the scientific phenomenon being modeled, and make modifications to improve it. Then they run new experiments with the modified model to determine the impact of their changes. With NSF funding, we are conducting a rigorous study of the impact of these units on students' engagement in the topics, their science achievement, and their interest in continuing on in a computer science or other STEM field. Teachers from 25 districts in Massachusetts and New Mexico have been implementing the units with their students as part of this study.
The units are phenomenal, the models are phenomenal, the units are super easy to follow. It tells you day by day what to do. It gives you all of the papers that you need for the students.
When they can take a computer model and modify it to match what they see in real life, I mean, that is exciting for them. That's empowering for them. That is huge in terms of their understanding of the concepts.
From biology to chemistry and physics, we hope Science+C will spur high schools to consider offering or expanding their computer science course portfolio and take the next steps to prepare their students for their future academic and career paths.